Lianyungang, on the coast of China's eastern province of Jiangsu, looks out across the Yellow Sea. Tianwan nuclear power plant stands here. The steam turbine generators of its reactors are running smoothly and efficiently. Nuclear power is one of the most efficient and cleanest ways of generating electricity. Tianwan generates 12 billion kilowatt-hours of electricity a year, which would give off 1.38 million tons of carbon dioxide if it came from burning coal. China has put 34 nuclear power units into operation in the past decade. That makes it the world's fastest growing consumer of nuclear energy. Central to the process is mega equipment used to convert steam into electricity. Creating it involves the most challenging manufacturing procedures, with the largest casting and heaviest forging. It's a domestically made AP1000 steam turbine low-pressure rotor, core equipment at the heart of nuclear power. Yangshan Deepwater Port is one of the largest ports in the world. It handles 40 million 20-foot equivalent units, or TEUs, per year, a full 1/10 of the entire global volume. With berths that are 15 meters deep, it can accommodate the largest 100,000-ton vessels. These great ships come and go, driven by mighty engines that power them across the world's oceans. Connecting the engine's pistons and the propellers they drive is one of the largest single components in marine engineering. At 23 meters long, it's the length of a high-speed railway carriage. This is the 12S90 heavy marine crankshaft. Electricity is the cornerstone of modern China's development. Hydropower and coal resources are mainly found in the country's northwest. But electricity consumption is concentrated in the country's economically developed and densely populated eastern coastal areas. To transfer electricity from the west to the east, Chinese engineers have built the world's largest electricity transmission network with the highest voltage level, the West-East Electricity Transmission Project. It covers most of the country and provides light and heat to nearly 1.4 billion people. Ultra-high voltage power transmission and transformer equipment, hidden in the network's core, is vital to the efficient operation of this supergrid. In addition to electricity, modern cities are also powered by gas. The 20 million people of Shanghai, for example, rely on a reliable daily supply of 34 million cubic meters. That's a volume equivalent to 10 times the city's tallest building, the Shanghai Tower. Like China's coal, the natural gas Shanghai needs comes from thousands of kilometers to the west. Chinese engineers have built the world's largest pipeline network to deliver it, the West-East Gas Pipeline Project. The network spans 9 provinces and regions, has a total length of 40,000 kilometers, and benefits more than 400 million people. Yet again, there is a vital core component to the network. Hidden in its depths is a 20 megawatt electricity-driven compressor that pushes gas across huge distances. One by one, these core pieces of equipment at the heart of great Chinese engineering achievements will be revealed. From initial concepts and research and development, to engineering and completion at world-class standards, Chinese mega equipment offers unlimited possibilities for the world of tomorrow. Electricity is the principal power source of modern societies. The subways and electric vehicles, workplaces and homes of cities today, and the data networks that connect them all, are all powered by this most useful form of energy. And one of the cleanest and most efficient ways to generate it is nuclear power. In Qiqihar, 1500 kilometers from Tianwan, engineers are building an AP1000 low-pressure rotor, the turbine that sits at the heart of gigawatt nuclear power plants. It takes three 350 bridge cranes 378 days to make this 12.5 meter long, 400-ton alloy forging. The marathon manufacturing process includes high-temperature smelting, forging by 15,000-ton free forging machines, and 13 complex processing procedures. In the smelting workshop, a batch of molten steel at 1600 degrees Celsius is nearly ready. Wang Quan needs to perform vacuum casting within 2 hours. Vacuum casting is when molten steel is poured into a vacuum chamber through a regulator called a tundish and cast into ingots. The problem is that the bridge crane's maximum lifting capacity is 350 tons, but the final cast will weigh 600 tons. How will Wang Quan's team solve the problem? Wang Quan decides to perform the cast with 3 ladles and 3 bridge cranes working together. Yet, even if 3 ladles continuously feed into the tundish, there will still be a time gap between them. So how can he ensure that the first ladle of molten steel will be fused and homogenized with the second and third ladles? A minor error may require all the molten steel, worth more than 10 million yuan, to be scrapped.
I can't relax for a moment until the last ton of molten steel is poured. I'm extremely nervous.
Wang Quan's plan is to add a specially formulated chemical component to the molten steel. He will do so according to an accurate calculation of the time difference, so that the 3 ladles of molten steel can quickly fuse and achieve homogenization. Now the ladles are in place, waiting for the slide gate of the tundish to open. The molten steel is injected, and Wang Quan is beside himself with anxiety. Molten steel oxidizes as soon as it meets air. If the gate fails to close normally, air and impurities will enter the tundish. They will immediately oxidize the molten steel, which will cause defects in the finished ingot. Thanks to the careful maintenance of the equipment, the slide gate opens as expected, and the molten steel is injected into the vacuum chamber smoothly. Vacuum casting like this can reduce impurities in steel ingots to less than 0.01%. The clock is ticking, and the 2-hour process is drawing to a finish. The casting is completed perfectly, and Wang Quan can finally relax. The hot molten steel will cool down into a hard ingot in 96 hours. This rough casting must then undergo a rigorous and exacting forging process to transform it into the finely engineered AP1000. Liu Bo-ming heads the hydraulic press forging team. His work is extremely demanding, but he never allows substandard products to leave the workshop. The ingot is 25 meters long and weighs 600 tons. Liu Bo-ming's team needs to complete the forging process in 40 days. Subjected to great pressure, the ingot begins to change. Its internal structure becomes tighter and more regular. To maintain its temperature, which is gradually decreasing, it is reheated to 1250 degrees Celsius. During the whole process, it will be reheated this way 13 times. This giant machine is a heavy free-forging hydraulic press, which can produce a pressure of 15,000 tons. Such enormous pressures are necessary for completing the task.
We use the press for a process called kneading to get the product into the required dimensions. Using cold working to attain precise results may take up 100 hours. Our precision forging can cut the time to 60 hours.
After the forging is reheated, the hydraulic press sets to work on it with enormous force. To turn it over, a steel turning machine is used, using giant chains to revolve it on its horizontal axis. To shape the forging, it can apply pressure to different parts as needed. Days turn into weeks as different exacting processes are repeated. At the end of the 40-day period, the forging is finally completed. At last, Liu Bo-ming can sit down and have a rest. Today's success has been won by completing the many similar pieces stacked around him. Chongming Island, an 80-kilometer-long alluvial stretch in the Yangtze River Delta in Shanghai, is a center of Chinese shipbuilding. The Shanghai shipyard, known as the China Merchants Machinery Shipyard in the late Qing dynasty, is located here. Today, another 10,000-ton ship is being launched. At the vessel's core is the crankshaft that drives its giant propeller. It needs no maintenance after launch and will continue working until the vessel is retired.
The crankshaft is the heart of the ship. The waves in the ocean are very strong, and the ship often needs to sail against them. Once the crankshaft stops functioning, disaster will immediately follow.
Far up the coast from Shanghai in the city of Dalian, engineers are building such a crankshaft. At 23.6 meters long and weighing 452 tons, it's still a work of great precision. An imbalance will prevent it from running smoothly and cause it to wear out prematurely. And a small defect could cause it to fail, with catastrophic consequences. Liu Zhongyou, the leader of the benchworker team, is in charge of heat shrink joining. Heat shrink joining means using the principle of thermal expansion. First, the crank web is heated to 450 degrees Celsius to increase the diameter of its bore. Then the crankshaft journal is inserted into the bore. When it cools, it will lock and become a whole crankshaft. The temperature must not be higher than 450 degrees Celsius. If the temperature is too high, it may cause changes in the physical properties of the metal, leading to an improper lock. and if the temperature is too low, the diameter of the bore will be too small for the journal to be inserted. Expansion must not exceed 0.3 millimeters. If improper temperature control causes the crank web to deform and fail to lock the journal in snugly, the crankshaft worth tens of millions of yuan will be directly scrapped.
My social media name is Rest. My job is very stressful, and I wouldn't rest even if they let me. There is always work to do, and I don't want any delay. The company gives us ice cream every summer. Others can have 2 or 3. I have the privilege of eating as much ice cream as I want.
This time the temperature of the crank web is perfectly controlled, and the degree of expansion is exactly 0.3 millimeters. Liu's efforts have paid off. A well-made crankshaft will power a ship on innumerable voyages without malfunction. In the machining workshop, a team led by Sun Pei-jian is also working on a tough challenge. Sun holds a record of working for 68 consecutive days in the workshop to overcome a technical difficulty. His job today is to operate a heavy computer numerical control machine to cut and polish the crankshaft and remove all imperfections on its surface. A general rule is that when a component is larger, a greater amount of inaccuracy can be tolerated. But this rule does not apply here. Sun Pei-jian must strictly control the degree of error when machining the crankshaft to between 0.05 and 0.02 millimeters, which is equal to 1/2 of the thickness of a human hair. He knows the influence of the smallest errors can be cumulative, combining to affect the safety of the ship.
We often say that everyone makes mistakes, but processing marine crankshafts requires us to never make mistakes.
The Three Gorges Dam in the central Chinese province of Hubei is the world's largest hydroelectric project. By itself, it generates 5% of the country's electricity. At the dam's substation, the generated current is boosted to a super high tension of 1000 kilovolts for transmission to the country's densely populated coastal region. More than 900 kilometers away in the Taizhou converter station in Jiangsu province, Robot Wally is on patrol, conducting routine inspection of power transmission lines. After long-distance transmission, the high-voltage electricity will be transferred to an ultra-high voltage grid here, and through the complex network of power grids, it will finally reach thousands of households. Robot Wally's eyes are a set of infrared sensing devices that can take accurate readings from various instruments and measure the temperature of the equipment. He checks whether the power transmission is normal through the changes in the line's temperature. The sculptures of the Silk Road in Xi'an, Shanxi province, were once the starting point of the ancient Silk Road. Just a few hundred meters away, a super factory is building transformer equipment with the highest voltage class in the world. Each ultra-high voltage transformer made here contains tens of thousands of components. To meet the task of long-distance, high-volume, low-energy loss transmission, Making one is a 120-day process made up of 32 rigorous steps. Coils are at the heart of any transformer. Zhang Guorong leads the factory's coil winding team. A single copper wire with a total length of tens of thousands of meters, and itself made up of dozens of thin wires, must be manually wound into coils weighing 20 to 30 tons. Because of the rare precision and importance of the winding work, the coil workshop where Zhang works is known as the Panda Workshop. Molding, winding, flipping, making S-bends, every step needs to be carried out with the utmost attention and care. Zhang Guorong's team must ensure that the dimensional tolerance of the coils is within 1 millimeter. If he exceeds this limit, it may cause a short circuit in the entire transmission network, as serious as that caused by a strong earthquake. The team also have to make sure the coils are of just the right tightness. If they're wound too loose, the product is not up to standard. And if the tension is too high, it may damage the insulating paper and cause a short circuit accident.
The one we're working on has 240 layers of coils. Although we can only finish 7 to 8 layers each day, they'll add up to a tall product like this if we keep doing it for weeks. That's our achievement.
A bright argon arc flickers in the cold workshop as the huge fuel tank of a transformer is meticulously welded. Once the tank is put into use, it will be filled with transformer oil. A single faulty welding point can cause a leak in the tank. This in turn can lead to the failure of a substation and even endanger an entire power grid, plunging a whole city into darkness. Wang Jianlue is about to do some electric welding. Although he has 20 years' experience of the technique, today his work is performed with the help of robots.
I might be able to perform a task perfectly only once, but a robot can replicate that operation. Many factors affect us, but robots don't have emotion. My new goal is to master operation of the welding robots, to elevate the welding work to a higher level.
Welding robots have become a hallmark of intelligent workshops. They can not only stabilize welding equipment and improve production efficiency, but also free people from harmful gases and repetitive labor. What Wang Jianlue needs to do now is master control of them. Elsewhere, in Xi'an's Gaoling district, this compressor station is one of thousands of the West-East Gas Pipeline project. The pressure of natural gas decreases during long-distance transmission, so compressor stations are required at intervals to maintain flow. Within them, 20 megawatt electrically driven compressors are vital pieces of equipment, pumping gas through the network for a steady and unbroken flow to China's densely populated coast. In the northeastern city of Shenyang, more than 1,000 kilometers away, one such machine is being made. When the impeller inside the compressor rotates at high speed, the natural gas is constantly sucked in and thrown forward. Ensuring the gas's continuing flow, this facilitates long-distance transmission. The 20 megawatt electrically driven compressor consists of 5 key components, including rotor, stator, and bearing. Building this core piece of equipment takes more than 130 days, hundreds of procedures, with accuracy required to within 0.8 of a micrometer. In the rotor workshop, Liu Duo and his team are facing a severe challenge. Natural gas is dangerously explosive. During the high-speed operation of the rotor, If its internal pressure is too high or the temperature rises too high, an explosion can easily occur. The rotor is the compressor's key component, and its lifespan determines the useful life of the compressor too. To be up to standard, the rotor's surface finish must be tightly controlled to within 0.8 micrometers, which is 1/60th of the thickness of a human hair.
If the centrifugal compressor is the heart of the process, then the rotor is the heart of the centrifugal compressor. The rotor is the only part of the compressor that does work, which means once it stops, the client would face immediate shutdown and suffer huge losses.
As the process advances, the surface of the rotor gradually becomes delicate and smooth. The required precision level of 0.8 micrometers has been attained.
The compressor is made to the strictest standards in the history of Shenyang Blower Works Group. Referring to international standards, we have further improved our precision requirements, which has further improved the quality.
In Shichiha, meanwhile, the AP1000 steam turbine low-pressure rotor is about to start the next step in its manufacturing process. Tang Liang, a bridge crane operator at the machining workshop, will steer her 350-ton machine to carry the forging from the forging workshop to the next station.
I'm 29 and I've been in the factory for around 10 years. The heaviest thing I've lifted weighs more than 400 tons. I love my job.
Over the next few months, sharp and tough alloy cutters will cut the bulky forging into a finely shaped turbine and smooth its rough and uneven metal surfaces. More important than a fine finish is that the giant rotor's internal structure is free from defects. The next step, therefore, is called ultrasonic flaw detection. Cao Zheyuan is the forging process's director. He knows the AP1000 must be perfect. The slightest flaw will be a risk for the operation of the nuclear power plant housing the turbine and may even lead to an irreversible disaster.
Its precision requirement is equivalent to not having even one crack that is as thin as a hair in a room-sized space. We try our very best to secure quality every day.
The ultrasonic flaw detection process begins. An ultrasonic probe is inserted into the interior of the metal. Cavities or cracks it detects will show up on a monitor, so engineers can determine when there is a defect inside the metal and its exact location. The final result is about to be revealed. If any defect is detected, the 378 days of manufacture and 14 complex procedures the rotor has undergone will all have been in vain. But the flaw detection process finally reveals there are 0 defects. At last, the semi-finished turbine is ready to leave the factory. The next stop for the AP1000 is a factory in Harbin, 260 kilometers away from Shichiha. Prior to its arrival, 2,060 exquisitely shaped and intricately carved metal blades have been meticulously milled and polished. Technicians will now carefully fasten the blades to the rotor. In all its splendour, the steam turbine is now finished. More like an artwork than a giant machine part, in itself it's a symphony dedicated to the industrial age. Its beauty, however, will soon be firmly hidden from view. Once at a power plant and securely installed inside its housing startor, steam generated from nuclear fission will drive it to rotate at high speed and convert the steam's energy into electricity. Ultimately, this electricity will light up the night sky of China.
The success of the AP1000 rotor has irreplaceable significance for nuclear power to go abroad and truly realize independent innovation.
China has to date built 8 large nuclear power plants. In terms of nuclear power generating capacity, it ranks 3rd globally. Long-term plans, however, should more than triple that capacity. In terms of shipbuilding, China already reigns supreme. Much of its capacity is on the Yellow Sea coast. It is here, in Jiangsu province, that a very successful type of small-scale, high-power and low-speed diesel crankshaft is manufactured around the clock. This kind of marine crankshaft holds the largest market share in the global marine crankshaft market. Small-sized marine crankshafts are more affordable and attract more demand than the heavy crankshafts installed in giant ships. This high-power model is the W6X35. Compared with heavy marine crankshafts, at only 4.7 meters long and 15.4 tons in weight, it's like a rolling pin. Yet it can still justly claim to be the #1 crankshaft of the world. In September 2015, the W6X35 was successfully launched in China, marking the end of a long-term monopoly held by developed countries on small-sized, high-power crankshafts. China is now able to domestically produce a full range of marine crankshafts. The W6X35 was the product of the ambition of a private entrepreneur, combined with the vision of a master crankshaft craftsman. Lin Yaowu has been making marine diesel engines and crankshafts for nearly half a century. He was part of the effort to develop China's first Type 60 large marine crankshaft.
Production of medium and large crankshafts had long been realized, but small crankshafts always haunted me.
In 2008, just as he was about to retire, a private entrepreneur found him.
At the time, the prospects for China's shipbuilding industry were promising, but our country couldn't manufacture marine crankshafts independently. So I came to Mr. Lin. I can't remember how much time we spent on it, but I know that we did it. We Chinese people are fully capable of building the best, strongest, and largest equipment in the world.
Today, a special friend is in the crankshaft workshop. Pugh Eisler is a marine diesel specialist who witnessed the W6X35 crankshaft being installed in the world's first X-series marine diesel engine. Ambition and dreams, of course, are not enough to build a high-quality marine crankshaft. A product must pass joint inspection conducted by a third-party inspection agency for ships and the company that made the diesel engine to obtain a certificate of compliance.
China is our #1 place because of big abilities, because of big resources. It is a big country, there is a lot of companies which need to compete between them. They are increasing their quality products, and what we can observe that actually China has future, and all this marine industry will be located in China.
Now let's return to the launch of a great ship from the Shanghai shipyard. Before that happens, a marine crankshaft is shipped to a marine diesel engine plant. Once there, it is installed in the ship's engine. After this, the whole diesel engine is shipped to the shipyard. In turn, it is then installed in the great ship. At the great vessel's heart, the crankshaft in its engine then sets out across the world's oceans.
After 10 years of development and 16 months of construction, we've successfully manufactured the first crankshaft. We've reached an advanced world standard.
The independent development and manufacture of heavy machine crankshafts not only shows that Chinese shipbuilding has risen to a world-class standard, it also facilitates China's rise as a major seafaring power. Back in Xi'an, an ultra-high voltage test is about to begin. This, in fact, is the world's largest high-voltage test site. Ultra-high voltage transmission and transformer equipment has been likened to a Pandora's box, full of enormous energy that can go out of control at any time. It must therefore undergo the strictest insulation performance tests. To carry them out, engineers will push the equipment to breaking point to find both its weaknesses and how to remedy them. The test room will simulate extreme conditions such as severe heat, cold, aridity, humidity and altitude. It will also mimic extreme weather like lightning and storms. And it will instantaneously flood the equipment with high voltage electricity of up to 1 million volts. All of this will test whether the equipment can cope with everything that is thrown at it. As the tests are taking place, the assembly of gas-insulated switchgear is in its final stage. In the fully enclosed and dust-free environment, components are meticulously installed into metal housings filled with insulating gas. Next, the assembled ultra-high voltage switch will also be put to a severe test. This is not the set of a science fiction fantasy movie, but an electromagnetic compatibility laboratory. In it, ultra-high voltage switches are subjected to the world's highest level of voltage shock. If it is interfered with by electromagnetic waves, a switch's control circuit may be accidentally triggered. The switches must therefore pass a test in such a laboratory, with walls and ceiling covered with geometrically shaped wave-absorbing materials. After the tests are all a success, the workers celebrate. Now it's time for the equipment they've made to be installed in its destination substation. Once there, it will fulfill its role as essential core equipment in the West-East electricity transmission project.
With the development of China's economy, the uneven distribution of resources in power consumption centers has spurred the development of ultra-high voltage power in China. This has also led world development of electricity equipment and power transmission.
In the Taizhou converter station, the UHV transmission equipment is running smoothly. During long-distance transmission, high-voltage electricity will inevitably release electromagnetic radiation and noise pollution. Thanks to superior electric field optimization design, this Chinese-made equipment reduces such adverse influences to a minimum. It is therefore both human-friendly and environment-friendly.
National standards require that electromagnetic radiation be no higher than 2,500 microvolts. Our product ends up with 16 microvolts.
The concept of human-friendly and environment-friendly is in line with national green power construction goals. It will enable China to lead the world not only today, but also in the future. Late autumn in northern China can be very cold, but this workshop is hot at night. The final assembly of a gas compressor is about to begin. From rotors and stators to cylindrical blocks and delicate bearings, the manufacturing process of each of more than 10,000 components has been carefully controlled. No matter how much theory is employed, the ultimate proof of any product will be how it performs. After strict quality control in its production, can the compressor cope with the complex climatic conditions and extreme geographies that natural gas faces during long-distance transmission? All will be revealed in the linkage test. On the test platform, pre-test preparations are underway. Each step in the test must be repeated, as the compressor will be running at full speed and full capacity, and any potential defect could trigger failure. The last 72 hours are the test's most crucial stage. Over a period of time that seems like an age, all the staff will stay in the laboratory to monitor the variation of parameters. They make rounds every half hour and change shifts every 24 hours. The test begins. The constantly changing data puts everyone on edge. The wait is tense and long. The test result will decide whether the team's 5 years of effort have been in vain.
The wisdom and sweat of all the engineers and technicians were poured into the project, from conception and engineering drawings to the manufacturing process. The pre-delivery test is the final inspection and verification of the compressor. The development of the compressor unit has succeeded only if it passes the pre-delivery test.
The 72 hours of anxiety are finally over. The test turns out to be a flawless success. Yet the joy in the team members' hearts is quickly overshadowed by sadness and reluctance. Sadness because they will be saying goodbye to the fruit of years of effort when the compressor is shipped out to start its working life.
We'll build the middle section of the third line of the West-East gas pipeline project, as well as a number of main lines, to form a huge gas pipeline network that covers our country and connects to foreign countries.
In the Gaoling station in Xi'an, the 20-megawatt electrically driven compressor unit is running smoothly. Early in the morning, a routine inspection is underway. Although there are hundreds of kilometers between the factory and the compressor's station, the people who built it know exactly how it is performing. Their monitoring can be achieved thanks to a remote system called Shanggu Cloud. Sensors installed in key parts of the compressor transmit its operating data in real time to the remote monitoring system. Through it, engineers and technicians can see clearly how the equipment they've made is running throughout the country and take immediate action if there's an alert. In China, more than 2,000 such compressors have already been made. They are now delivering 16.5 billion cubic meters of natural gas yearly to cities and remote areas. From molten steel to a sophisticated steam turbine, from hard and cold alloys to a powerful marine crankshaft, from thousands of separate components to a compressor driving gas across China's vast landmass, and from copper wire to coils that achieve the same long-distance feat for electricity. The story of core equipment at the heart of advanced Chinese engineering systems has only just begun. The manufacturing continues in factories around the clock. Robot Wally's infrared temperature measurements continue in the Taizhou converter station. Another marine crankshaft is installed into a mighty diesel ship engine. Clean electricity is transmitted to cities efficiently and safely from nuclear power plants. In the near future, super equipment will change not only China, but also the world.